Okay, so we will start now. So, good evening, everyone. In yesterday's class, we have studied basics of trigonometry, and today we will start the differentiation part. So, I think differentiation is one of the most important mathematical tool which you will find in physics, because in all derivations you will find the use of differentiation or derivatives. So, am I audible? Like, can you just type yes or no in chat so I can proceed further? Okay, thank you. Mm. So, differentiation is basically a process of finding derivatives of different functions. So, like, let's say we can have different kind of function, like f of x is equal to, let's say, x square plus 2x plus 4, or f of x is equal to sine x plus cos x. So function can be of any type. So differentiation is basically process of finding the derivative of that function. Okay, so let's see the mathematical definition of differentiation. So, or like, sorry, let's see, like mathematical way to find out derivative of given function. So if we have any function f of x, let's see how to find its derivative. So first thing I want to tell you, like, derivative of function f of x is written as f dash of x, or if you again take its derivative, then you can write it as f double dash of x. Or if you write your function as, let's say, y, then its derivative can be written as y dash. If you again take its derivative, then you can write it as y double dash. Okay, so let's begin with the definition of derivative. So if you have a function f of x, then its derivative f dash of x is given as limit h tends to 0 f of x plus h minus f of x divided by h, and here h is small increment in x. Okay, so first of all, here we have seen there is a so if we have function f of x, its derivative f dash of x can be given as limit h tends to 0 f of x plus h minus f of x divided by h. So concept of limit, I think, if you have not taken mathematics course, then just for introduction I will tell. So if someone tell you find if limit x tends to 3, find the value of x square plus 2 divided by x. So in this case, you can directly put x equal to 3, because they are telling us like x is almost 3, not equal to 3, but it is almost 3. So if you put here the x equal to 3, then you will get 9 plus 2 by 3. So it will be 11 by 3. So like that, you solve the limits. And if this actually this was really a simple example, but in case if you take means there are, if there is a difficult problem, then there are different rules in solving limits. But I just for introduction, I wanted to tell how you put this value here. uh, that's why I have given this example. So let's say the definition of derivative is, if we have function f of x, then its derivative f dash of x is given as limit h tends to 0 f of x plus h minus f of x divided by h. So here what they want to tell is, what they wanted to tell is, see, if you have function f of x equal to x square, let's say, then how we will find its derivative is, uh, let's consider h as very small increment. Then f dash of x will be limit h tends to 0, x instead of x plus h square, because since f of x is x square, f of x plus h is x plus h square. So here we will solve it as x plus h square minus f of x. So it is minus x square divided by h. So let's expand this. So what we will get is limit h tends to 0, x square plus 2xh plus h square minus x square divided by h. So x square will get cancelled. Then we take, if we take h common from both, what we will get is limit h tends to 0, h into 2x plus h divided by h. Again here h and h will get cancelled. So now if you put h is, as you know, h is almost equal to 0. If you put h equal to almost 0, what you will get is 2x. And therefore derivative, if f of x is x square, its derivative f dash of x can be written as 2x. So this is how mathematically we find out the derivative of a function. Now let's see what they wanted to tell, like what is the meaning of derivative. So here what we have done is we have f of x given. Okay, now instead of x, let's say f of x, it will give you, let's say it is a function like x square plus 2x is f of x. So what you are doing is considering h tends to 0, means h, that the increment is very, considering the increment is very small, you find out x plus, what is f of x plus h, and then you will get certain value like x plus h square plus 2 into x plus h. Now you are finding difference in the, means since you are subtracting f of x from f of x plus h, basically you are finding the difference in these two values. Okay, so and then, so according to the definition, limit x tends to 0, this f of x plus h minus f of x, that is the difference or increment in or decrement in this function, difference divided by h. So basically what you are trying to find out, if you change or increment the like if you increase the value of x by small value h, then mm, okay, if you increase the value of x by small value h, then how much increment in function you get with respect to that increment, so that is what is the derivative. So you can say it is measure of how a function's output value changes with respect to change in its input value. So here h is basically change in input value, change in input value, and f of x plus h minus f of x minus f of x is change in output value. So once again, I just wanted to tell you, like if again, if you have function f of x is equal to x square plus 5x plus 6. So here value of x, it can be 1 or it can be 2, or it can be 3. So this is the input value you are giving. for the given input value you are getting some output, like f of 1 you are getting as how much, 1 square plus 5 into 1 plus 6, so it is like 12. So this is the output value you are getting. For input value x equal to 1, you are getting output value 12. So now if you increase the input value 1 from 1 point, let's say very small value as it is tending to 0, 1.000001, then you will get some value of some output value like 1.000001. You will get some, let's say you get some value b. So the change in so the definition of derivative is basically it tells you how this output value changes. So like b minus 12 is a change in output value with respect to this increment. So increment is this value of x minus 1, so it is like 0.00000. So with this increment, how much change in this output value you got is basically derivative of that function. Now, the differentiation determines basically the instantaneous rate of change of output with input. So why they have told like instantaneous? It is instantaneous rate of change of output with input. So let's see this graph. Okay, in this graph, if this is f of x and this is x, so let's say for some value of x, you the value of f of x, this is the value of f of x. Let's say value of, if it is a, then it is f of a, and here at some value of when x equal to b, so this is the function, basically function f of x. Okay, so at some value of when x equal to b, the value of f of x will be f of b. So if here you find f of b minus f of a divided by b by a, so it will be basically average change in value of function with respect to change in value of input, that is x. Okay, but if this b minus a, if if these 2 points are like very close to each other, one point is here and second point is overlapping, and the difference in b minus a, like if they comes so close to each other, this like if a comes here, b comes here, they are almost touching each other, and if this b minus a is tends to 0, then the change in function with respect to change in value of x will give you instantaneous variation of that function. Okay, that's why. And so according to the definition of this differentiation, we have learned that if the increment is h tending to 0, then this change in f of b minus f of b or divided by b minus a tells us the derivative, and therefore it is known as instantaneous rate of change of output with respect to uh, input. Okay, next thing is, so let's say this curve, we are having this curve, let's say it is f of x equal to some x square plus 2, or it is some curve like this. Okay, now if we draw a tangent to this curve at some point, then the slope of this tangent is like given as this. If this angle is theta, it is given as tan theta. Okay, and if we try to zoom, like I already told, uh, okay, 1 second. So see, if you, as this line is representing like this point is f of b, sorry, b comma f of b, and this point is a comma f of a. If we draw it on, because x coordinate is a, y coordinate is f of a, here x coordinate is b, y coordinate is f of b. Okay, so if we start bringing this point a and point b closer and closer, so such that the distance between a and b, like distance between a and b, like b minus a, almost tends to 0. So in this case, if this distance, let's say this point comes here, b comma f of b and a comma f of a, they come so close that the distance b minus a, if the distance b minus a almost tend to 0, then this line, then this 1 second, then this line connecting these 2 points will almost overlap with the tangent to this circle, sorry, tangent to this curve, and therefore we call therefore the uh, therefore this what the slope of this function, slope of this function at this point is equal to derivative of that function at that point. So differentiation will also help you to find out derivative, sorry, the slope of the uh, curve at this point. So here, let's say this, since this is in x y direction, this distance is y dy, or df of x, change in f of x, and this distance is dx, as this is different in x direction. So this slope of this tangent, which is equal to tan theta, you have studied this in your school, which is equal to df of x by dx. So okay, so here I told you that derivative is written like f dash of x, but you can write it as d by dx of f of x also. So both are same thing only. Okay, so if we have function y equal to, let's say, x square plus 2, then its derivative can be given as y dash, or it can also be written as dy by dx. Okay, so in physics, like differentiation is used to calculate quantities like velocity. Okay, so miss, when I will start teaching you about rectilinear motion, so you will find that the, if you have displacement as s, since it is vector, I have written it is like that. So its derivative, basically ds by dt with respect to time, is known as velocity. So, and if you take its double derivative, so its double derivative can be written as d square d2s by dt square. So double derivative of displacement will basically give you acceleration. So means this has many applications in actual physics. It will help you to find maxima, minima, and it will help you in analyzing problem related to motion, as I told, then decay and growth processes. So this was the basics for differentiation. So okay, I think okay. So what is H? Okay, sorry, I saw it very late. What is H here? So okay, I will go there. Okay, so the definition, like how to the derivative of f of x, like was f of f dash of x was limit x tend sorry limit h tending to 0, f of x plus h minus f of x upon h. So in this case, like if you have a function f of x equal to x square plus 2x, okay, and if I told you to find out like value of this function at f equal to x equal to 1, at x equal to 1, so you will get f of 1 equal to 1 square plus 2 into 1, that is 1 plus 2 equal to 3. So h here is small increment, h is small increment in x. So it is infinitesimal. Infinitesimal means it is tending to 0. So if the value of x is equal to 1, then h can be like very small increment, like 0.0000001. So uh, do you have any more question like related what is h? So here, hello, Reet, do you have any question like related to h, or you understood what is that? Oh, okay. Mm. Okay, just give me 1 second. I will try to. Second question was from Vinita. Okay, sir, do they ask to derive? No, they don't. They won't ask you to derive. This is the mathematics. Miss, I am teaching mathematics only because it will help you in understanding physics, and they won't ask you to derive anything. Okay. Mm. So here, let's say now you have function f of x is equal to x square. Okay. So here on this graph we have drawn this function f of x. Here on y-axis it is f of x, and here on x-axis it is x. So when x is equal to 0, this f of 0 will be equal to 0 square. It is equal to 0. When f x equal to when x equal to 1, f of 1 is equal to 1 square and it is equal to 1. When x is equal to 2, f of 2 is equal to 2 square, that is 4. Okay. So for x equal to 0, you found the value of function to be equal to 0. When x equal to 1, you found that the value of function equal to 1. When x equal to 2, the function is equal to 4. So let's say this is first point. This is x equal to 1, function is also equal to 1. When x equal to 2, this function is giving value equal to 4. Similarly, if x equal to 3, f of 3 will be equal to 3 square, that is equal to 9. So when x is equal to 3, this function value is equal to 9. So here it is 0 0. So when you moved from, let's say, 0 to 3, okay, when you moved from 0 to 3, the function value changed from 0 to 9. So let's say we write change in the value of function from, let's say, when we moved from 0 to 3, uh, function value functions value changed from 0 to 9. So let's write one function. Let's write one equation that is basically change in function value divided by change in x, or you can call this change in x as you can call it as increment in x. Okay, so how much it is? It is change in function value is like 9 minus 0, and change in x or increment in is x is 3 minus 0. So you got value equal to 3. Okay, so in this case we have seen the increment in x was from 0 to 3. So and for that you got change in function from 9 to 0. Okay, for 0 to 9. But if you consider a case where instead of moving from 0 to 3, you have moved from 0 to 0 point, let's say 0.000001. So in this case the increment was 0 to 3, it was large increment. But if this increment you have, in this case this increment is almost tending to 0 or almost equal to 0. So whatever the value of this equation, like change in function value by, and you, if you write this increment as h, okay, if you write this as h, so whatever, so for, so you, what you are writing is, so when h is, this increment is very small, so when this increment or this h is tending to 0, so for showing that we write it as limit. So when this increment is tending to 0, the difference here. So here, see, here when you have inserted x equal to 3, you got 9. But here now, if you put x equal to 0.000001, you will get some value. Okay, since it is square, it will be like 10 to the power minus 12, like it is very small value. Okay, this value you will get here. This is 10 to the power minus 6, its square is 10 to the power minus 12. So when this, one second. Okay, we have some space here. Okay, so when this increment h, or this increment is tending to very small, or it is tending to 0, when h is equal to very small, which is tending to 0, so in this case, if you find, so let's say earlier your x was 0, so therefore f of x was also 0. Now your x is h, which is tending to 0. So here you can write like, or you have increased the, one second. Okay, here x is equal to 0, and f of 0 is, therefore f of x, that is f of 0, is equal to 0. Now you write, you have increased the value of x by h. So here you write it as x plus h. Okay, but your x is already 0 and h is like very small. In this case, f of x plus h will be, since this is like 10 to the power minus 6, and when you take its square, it is 10 to the power minus 12. So therefore, for this function, limit h tending to 0, f of x plus h minus f of x by h, this is basically giving us the value of derivative of function x square at x is equal to, uh, means if you put the value, then you will get basically the derivative at x equal to 0. Do you understand the difference, or you still have a question? Can I proceed further, Reet? Okay, thank you. So this was the mathematical definition of differentiation or derivatives. So let's see some like method to remember, or means every time you will not put this formula like limit h tends to 0, f of x plus h minus f of x by h to get the value of derivative, and therefore you will have to remember some formulas and some and derivative of some functions. So let's say if, okay, so let's say if y equal to constant, some constant value like y equal to 2 or y equal to 3. Here y is f of x only. Okay, don't get confused. F of x and y are same. You can represent this in any manner. So if you have y equal to 2, y equal to 3, or y equal to 1000, some constant value, then its derivative, which is given as dy by dx, or y dash is equal to 0. Okay, you can prove this by the above mathematical identity. Okay, but I don't think it is required now. You just remember that when function is a some constant value, then its derivative is 0. Now if you have a function like y equal to x to the power n, so in this case the derivative of y, which is dy by dx or y dash, is given as n times x to the power n minus 1. So let's say if you have y equal to x, so in this case the power of x is 1. So in this case n is equal to 1. So therefore for this question y equal to x, y dash can be given as 1 into x to the power n is 1 minus 1. So it is 1 into x to the power 0, that is 1. So if y is equal to x, y dash is equal to 1. One more thing here, always remember that here we are finding the derivative with respect to x, so it is dy by dx always. Okay. Mm. So derivative of y equal to x with respect to x, that is y dash, that is equal to 1. Now if we have y equal to x square, so the formula was y dash of x to the power n was y dash of x to the power n. If y equal to x to the power n, y dash was equal to n x to the power n minus 1. So here in this, when y equal to x square, y dash is equal to, this is y dash is equal to, and here is 2 into x to the power 2 minus 1. So it will give 2 into x to the power 1. So x to the power 1 is x only. So it is 2x. So if y equal to x square, its derivative y dash is equal to 2x. And this identity we have seen earlier using the basic definition of differentiation or derivative. So you can compare like that. Similarly, if y is equal to, let's say, x to the power 5, its derivative, so here in this case n is equal to 5, so y dash is equal to 5 x to the power 5 minus 1, that is 4. Okay, so if we have y equal to x to the power 10, then y dash is, n is 10, so 10 x to the power 10 minus 1, 9. So this is how you find the derivative of a function which is of form x y equal to x to the power n. And earlier we have seen when y is constant, its derivative y dash is 0. Just give me 1 minute. Okay. Okay, differentiation, like it will be useful in like many derivations, like in, like in physics you will see some derivations, and differentiation is the like basis of all the derivations you will see. Like I told, for velocity, displacement, like velocity is basically differentiation or derivative of displacement, like that acceleration is differentiation of velocity. So in physics it will be very useful, all those things. So this formula, like now whatever I'm telling, the formula which I told, like about for y equal to constant, differentiation is 0 or derivative is 0. For y equal to x to the power n, kind of, if function is of that kind, then differentiation y dash is n x to the power n minus 1. So all this you will have to remember. Okay, so let's come to the derivative of trigonometric function. So let's say if you have function y is equal to sine x. So again, we'll go to the basic definition of differentiation. So if y equal to sin x, it is derivative y dash. First of all, okay, y dash can be given as limit x tends to 0. Here y of x, like here y or y of, it is y of x or y is equal to sin x. So okay, y of x plus h minus y of x divided by h. So sorry, here it is h tends to 0. Okay, so so when we will solve it, limit h tends to 0, here instead of y now we will write sin x plus h minus sin x divided by h. So what we will get, limit x tends h tends to 0. So yesterday we have seen the expansion of sin a plus b. So here similarly we have sin x plus h. So the expansion of sin x plus, so sin x plus h is equal to sin x cos h. This we have learned in trigonometry class, plus cos x sin h. Okay, so yesterday we have seen one more concept, like theta when theta tends to 0, then in this case sin theta is equal to theta, tan theta is equal to theta, and cos theta is equal to 1. So as we know that here h tends to 0. So when h tends to 0, cos h is equal to 1. Similarly, sin h will be equal to, so sin h, so sin theta is equal to theta, so sin h will be equal to h. Okay, so therefore this simplification, after putting cos h equal to 1 and sin h equal to h, the value of sin x plus h, wait, I'll write here, sin x plus h is sin x cos h plus cos x sin h. So as we have seen, the cos, when h tends to 0, cos h equal to 1 and sin h is equal to h. So this, after expanding this, we will get this is equal to sin x, because sin x into 1 is sin x, plus cos x h cos x. Okay, so we will write this value here, that is sin x plus x cos, sorry, h cos x plus h cos x minus sin x divided by h. So sin x got cancelled with sin x. So here what is remaining, h cos x. So h got cancelled with h. Since h has gone, this there is no point in considering any limit. So we are remain only with cos x. So therefore, if y equal to sin x, the derivative of y dash is equal to cos x. Okay, I don't want you to solve this like this. It will be better if you remember these derivatives of these trigonometric functions. So for other trigonometric function, I will write it down directly, and it will be better if you by heart this part. Okay, so if y equal to, we'll start from beginning. If y is equal to sin x, then y dash, or dy by dx, or derivative of y will be equal to cos x. Similarly, if y is equal to cos x, then in this case y dash or dy by dx is given as sine x. You should remember all these things actually. It will be really helpful in your question solving. It means direct question won't come from this part, but in other question it will be really helpful for solve them. So if y is equal to tan x, then y dash, which is dy by dx, will be equal to sec square x. If y is equal to sec x, then y dash or dy by dx will be equal to sec x tan x. Similarly, if y is equal to cot x, then y dash is equal to dy by dx will be equal to minus cosec square x. For y is equal to cosec x, y dash or dy by dx is minus cosec x cot into cot x. So you should remember all the six derivative of all the six trigonometric functions. Like if it is sin x, its derivative is cos x. For y equal to cos x, its derivative is minus sin x. Then for y equal to tan x, its derivative is sec square x. Then for y equal to sec x, its derivative y dash is equal to sec tan x. Then for y equal to cot x, its derivative is minus cosec square x. And for y equal to cosec x, its derivative is minus cosec cot x. So any one of you have any questions till now? Please say yes or no in at least in chat box, so it will be helpful for me to proceed further. Okay. Actually, I forgot to give few more identities. I will just write those down. So like we have seen the formula, like if y of is of form x to the power n, its derivative y dash is equal to n x to the power n minus 1. Okay. So what if y is equal to 1 upon x? So in this case, we can write this 1 upon x as y equal to x to the power minus 1. So in this case, n is equal to minus 1. Therefore, its y dash can be written as minus 1 into x to the power minus 1 minus 1. So it will give you minus x to the power minus 2, or you can write it as minus 1 upon x square. Okay. So the derivative of y is equal to 1 by x is given as y dash is equal to minus 1 upon x square. So whether n is positive or negative, you can use same formula. Also, if it is a fraction, so let's say if y equal to root x. So in this case, you can write y is equal to x to the power 1 by 2. So here we got n is equal to 1 by 2. Therefore, the derivative of y equal to root x can be given as y dash is equal to n. N here is half x to the power half minus 1. So it will give you half into x to the power minus half, or you can simply write it as 1 upon, one second, I am facing some issue with writing. Okay, so you can simply write this as 1 by 2 into x to the power minus 1 by 2, which is equal to 1 upon 2 root x. So you can use this formula. Uh, you can use this formula whether the n is positive, negative, or it is a fraction. Okay. So derivative of root x is 1 upon 2 root x. Now we will see the derivatives of logarithmic and exponential functions. Okay. So let's say if you have y equal to log of x, so its derivative can be given as y dash is equal to 1 upon x. And I will recommend you that you should remember all these derivatives, because it it will be useful for you in solving questions. So similarly, if you have y is equal to e to the power x, then its derivative is given as e to the power x only. So when you take derivative of e to the power x, its derivative is equal to its actual function only. Like derivative of e to the power x is itself e to the power x. So it won't change. The next thing is y is equal to a to the power x. So if you have some constant a, and if you have to find the derivative of y equal to a to the power x, then it is given as y dash is equal to okay, if you have function of type a to the power x, then its derivative y dash is given as a to the power x log a. So if the here a can be any constant, so like if you have y is equal to 5 to the power x, then its derivative y dash is given as 5 to the power x log 5. Or if it is y is equal to 100 to the power x, then its derivative y dash is given as 100 to the power x log e 100. So you better you remember uh, all these formulas or all these so that it will help you in solving questions. Actually, notes, I will share it on WhatsApp group most probably, and maybe I will share those notes within 2 3 days. I require some time to uh, make it in a proper manner. So means before next class, definitely I will share the notes of this previous two classes. So let's see the addition of subtraction. So earlier, whatever we have seen, like y was here, if we have y as x square or y equal to log x, we have seen function like this. But what if we have function y equal to x cube plus 4x square plus 3x plus 4. So in this case, if you have to find out derivative, so if you have to find dy by dx, you can simply write it as d by dx of x cube plus d by dx of 4x square plus d by dx of 3x plus d by dx of 4. So there is nothing special in if nothing special if we have a function of kind function which involves addition or subtraction. So even if it was like -4 here, so only the minus it here only minus sign will change, so everything will remain same. So in addition or subtraction, so if you have function with addition or subtraction of uh, multiple terms, then you can separate out those terms and take their derivative and add them. So here in this case, dy by dx can simply given as, so for x cube, what will be the derivative? As we have seen, for x to the power 1 n, it is n x to the power n minus 1. So for x cube, it is 3x square. Okay, plus for 4x square, it is 4 will come outside. It is, since it is a constant, it will come outside. And for x square, it is 2x. Similarly, for 3x, 3 will come out, and for x, it is 1. Derivative of x is 1. And since 4 is here, it is constant, its derivative is like 0. So here dy by dx, what we got as 3x square plus 8x plus 3. Okay. So there is no special rule for addition. You can simply separate, find the derivative of these terms and you can add them. Okay. So similarly, let's take one more example. Like if you have a y is equal to log x plus cos x plus 5x square, then its derivative y dash, or which is equal to dy by dx, can be written as the derivative of log x was 1 upon x. Derivative of cos x is minus sin x. Then the derivative of 5x square. So as I told, 5 will come out. Then for x square, it is 2x. So finally, we got 1 by x minus sin x plus 10x. So this is the derivative of above given function y. Yes, e is the base of log, correct. Now we will see the product rule. Product rule means uh, if you are having, let's say, y is function like y is equal to x sine x. So it is multiplication of two terms, right? One is x and one is sine x. So how you will find out the derivative? So let's say we write y as y is equal to u and v, and both u and v are different functions. So its derivative dy by dx is given as u dv by dx. We'll take u as a constant, we'll take it out, and we'll find derivative of v. So it is dv by dx plus, then we will take v as constant outside and take derivative of u. Okay, so if y is function of u and v, and u and v are two different functions, then dy by dx is given as, first we'll take u as a constant and we'll take derivative dv by dx. So it is u into dv by dx plus v into du by dx. So now if y is equal to x sine x, so in this case dy by dx or y dash is given as, first you will take, we will take x outside as a constant, and we will take derivative of dy dx of sine x, and then we will take sine x out, and we will take derivative of x. So the derivative of sine x is cos x. So here it will we will get x cos x plus sine x into derivative of x is 1. So it is just sine x. Okay. So this is basically a product rule. We will take one more example to see it. Okay. So let's say now you have y is equal to x square e to the power x. So again, what we will do is, here we have u, here we have v. So what we do is u, to find y dash, what we do is u derivative of v plus v derivative of u. Okay, so this is how, here if let's say x square is u, so we will take x square outside, derivative of d by dx of v. Here v is e to the power x. Then we will take e to the power x outside, and we will take derivative of x square. So derivative of e to the power x is e to the power x itself. So here we got x square e to the power x plus, here derivative of x square is 2x. So here we got 2x e to the power x. So y dash is basically x square e to the power x plus 2x e to the power x. Now we will see the division of two, if y is a function which is division of two different functions. Okay, so let's say now y is equal to sine x divided by x. So one thing you can do is, like, you can write it as x to the power minus 1 sine x, and again you can use u into v rule, which is a product rule. But now we are going to see, but if it was not sine x, or if it was, like, let's say it was sine x upon e to the power x, then of course you cannot okay, in this case also you can make it like e to the power minus x sine x, and you can apply uv rule. But there is one more rule, which is a division rule, which we will see. So if y, let's say if y is equal to u by v, then y dash is given as v into derivative of u minus u into derivative of v divided by v square. Okay, so this is the formula. You should remember this formula. So the formula is, if y is equal to u upon u divided by v, numerator is u, denominator is v, then y dash is given as, first we will write v into du by dx minus u into dv by dx divided by v square. So if we have y is equal to sine x upon x square, so in this case y dash is given as, first v, so here u is sine x and v is x square. So we will take v, that is x square, then derivative of sine x minus u. So here u is sine x into derivative of v, that is x square, and whole divided by v square, that is x square of x square. Okay, so here you got x square. The derivative of sin x is cos x minus derivative of x square is 2x. So here you got 2x sin x divided by x to the power 4. So this is how you do the division. So any one of you have any question in multiplication or division? Please ask if you have any question. No questions. Okay, then I will move forward. I think we'll wait for 2 minutes and then we'll start. Just 2 minutes, or we'll wait for 5 minutes. So if you want to have water or you want to go to washroom, please do it. We'll start in like 5 minutes, like at six, before around 6:15 we will start again. Hello. Are you there? Like, means, can I start the class? Please reply in chat box. Oh, okay. Sorry. Okay. Okay. So we'll start with chain rule. So, let's see what is the chain rule. So if you have function, y is equal to, let's say, sine x square. So like we have seen, like since we are taking derivative with respect to x, like when we see y dash, it is derivative with respect to x. And here what we are saying is, here this the term which is inside sine is also a function of x, and it is not x. So let's write it down, it as, let's say we write it as sine big X. Okay, and where x is x square. Okay, this is bigger x and this is smaller x. Okay, so if we have to find y dash in this case, what we will do is, we will first write down y is equal to sine x. So we will find out the derivative of y equal to sine x as it is. So what is the derivative of y sine x? So it is cos and bigger x. And now into, we will find the derivative of this function x. So it will be like dx by small dx. So when instead of x, the function is having the function of x, here we don't have simply x, but we have x square. So in this case, what we have done is, we have written this x square as some other term, it as x. Then we have taken the derivative of this sine, so it has become like y equal to sine x. So that we have taken derivative of sine x, it has cos x, which is cos x, and into, we write it as derivative of that bigger x by x. So here what we have is cos big X into, okay, so now we will resubstitute this big X, what it is x square. So after resubstituting, what we got, cos x square into d by dx of x square. So what we got here is, so derivative of x square is 2x. So what we got is 2x cos x square. Okay, I will show one more example, so it will become easier to understand. So let's say if y is equal to log of sin x. Again, here this inside log we have one function. So here we will write this big X as sin x. So here the derivative, so y will become log e of this big X. So dy by dx y dash, or dy by dx is can be given as derivative of log x, as we have learned it as 1 upon x. Then we will take through chain rule, we will write d by dx of bigger x. So it will, now we will resubstitute that x equal to sin x. So what we will get, it as 1 upon sin x into derivative of sin x. So derivative of sin x is cos x. So we got cos x divided by sin x. We'll take one more example because it is like crucial to understand this concept. So let's take, let's we have y is equal to cos x square plus 4. So again, we don't have simply cos x. So here we will write this term x as x square plus 4. So the y has become cos big X. Then its derivative y dash can be given as dy by dx is equal to, first we will take derivative of cos x. So derivative of cos x is minus sin x, and then we will take derivative of this big X, like dx by x. One second, I have not done. Okay, so now after, now we will resubstitute this value of x. So what we got is sine minus sine x square plus 4 into d by dx of x square plus 4. So the d by dx of x square plus 4 is basically 2x, plus derivative of 4 is 0, so it is 2x. So what we got is minus 2x into sine x square plus 4. Let's see, now now we will try to take one more example which will have three functions. Let's see, y is equal to log e into sine of e to the power x. So the value, so here even sine x means the sine, whatever is there inside sine is also a function of x, and it is not x. So let's assume y, we will assume bigger y is equal to e to the power x, and it is also function of x. Then we will assume sine, or let's say we will assume sine e to the power x as some bigger y. Okay, so what we got log, and here this is function of x only. Okay, so y has become log e of y. So if we take its derivative dy by dx, it is 1 upon y dy by dx. So now let's substitute y. So here y, capital Y basically, capital Y is sine e to the power x, and here d by dx of sine e to the power x. Okay, so this term it already came out of the derivative sign. Now again we have sine to the power, sine into sine of e to the power x. So let's write capital X as e to the power x. So to solve only this part, how we will do is we will substitute e to the power x equal to capital X. So again, using chain rule, let's keep this outside on the sine because it is outside derivative. Okay, so derivative of sine x, so it is cos x, capital X, into dx by d capital X by d small x. So here we got sine e to the power, sine of sine e to the power x cos x. So again resubstituting this capital X, so here you got cos of e to the power x into derivative of e to the power, here x is e to the power x, so derivative of e to the power x is e to the power x. So here is, you got this. So this is how, like, you can first substitute some function like x and y, and then you can solve it using chain rule. Now let's move to the double differentiation. Okay, so double differentiation is like, if you have, as I told, y is equal, let's say we have y is equal to x square. So first differentiation of y dash, so how we find out n into x to the power n minus 1. So here y dash is basically 2 into x. So again, if you differentiate this, so dy by dx, here it was it is represented as y dash equal to 2x. But if you again differentiate it, so it will become d2y by dx square equal to, it is represented as y double dash, and it is basically derivative of this 2x, because we have already differentiated y for one time and it gave us 2x. So second derivative, to take differentiate it again, we will just differentiate this y dash, which is equal to 2x. So differentiation of 2x is basically 2. So double differentiation of y equal to x square is y double dash, which is equal to 2. Similarly, if we have y is equal to sin x, then its first derivative y dash is equal to cos x. And again, if you differentiate it, so it will become like d by dx of cos x, and d by dx of cos x is minus sin x. So double differentiation is like differentiating that function twice. I think you can easily understand. So if you take the example of y equal to e to the power x, so you know that no matter how many times you differentiate it, like if you differentiate it twice, thrice, or 4 times, it will give same value, that is e to the power x. So double differentiation of e to the power x is e to the power x. So now we will see the concept of maxima and minima. So previously, uh, we have seen the derivative of a function gives slope of that function. Okay, so from this graph, let's say we have a graph y versus x. We have two graphs. Okay, so you can clearly see that this point is showing the maxima for this function. Let's say this is some function y. We don't know it can be anything. Here also it is function y. So this point is basically showing the maxima of this function. And if we draw a tangent at this point, so for this tangent, the slope of this tangent is 0. So if we consider this function y, and if we take its derivative, so derivative, since derivative is equal to slope, so this derivative will be equal to 0 when the point is maxima. Okay, similarly in second curve also you can see this point is showing basically, so here it was maxima, so in this curve this point is showing minima. Okay, if you see this curve, this point is showing minima, and again if you draw a tangent to this curve at this point, it will show you the slope equal to 0. And you, as you know, slope is the derivative of that function. So derivative of that function at the minima is 0. So if you have to find the point of maxima or point of minima, you, for what you will have to do, if I give you some function, let's say y equal to x square plus 4x plus 3, and if I ask you to find out the point of maxima or minima, then what you will do is you will differentiate it. You will find dy by dx, let's say, so its differentiation is 2x plus 4, and then you will equate it to 0. So from this equation you will find the value of some, let's say in this case is the value of x equal to -2. For x equal to -2, there will be either minima or maxima. So to find out whether it will be a minima or maxima, what you will means in both maxima and minima, like for both maxima and minima, slope of the tangent to that curve or differentiation at that, like slope of maxima, let's say for both maxima and minima of function, slope of tangent to that function is 0, and slope is given by differentiation, so it is given as dy by dx slope. So based on that, you can find out the point of minima and point of maxima. So let's, as we have seen the example, if we have x square plus 4x plus 2, let's say we have function or curve with equation x square plus 4x plus 2, then in this case its derivative, if we have to find the point of maxima or minima, what we will do is we will find out its derivative y dash or dy by dx, and we will equate it to 0. So its derivative is y dash is 2x plus 4, and now we will equate it to 0. So we will get x is equal to minus 2. So this is the point of maxima or minima. X equal to minus 2 is point of maxima or minima. Now if you have to find out it is exactly a maxima or minima, what we will do is we take its double derivative. So we will find y double dash or d2y by dx square. So if the double derivative or y double dash is greater than 0, then this means then this is a point of minima. Or if y double dash or derivative is negative or less than 0, then this is a point of maxima. Okay, so in this case what we got is the point of minima or maxima as x equal to minus 2. So let's find its double derivative. So double derivative of this 2x plus 4 is or this y, double derivative of this y is basically 2. So since 2 is a positive number, uh, since 2 is positive number, this x equal to minus 2 is showing us basically a minima. So let's take two example. So first is find the value of x that minimizes function x square plus 4x equal to 6. So the given function is, again actually this pen started giving some issue. Okay, given function is x square plus 4x plus f of x equal to x square plus 4x plus 6. Okay, so if we have to find its, or let's say y is equal to f of x. Okay, so now if we have to find y dash, so y dash is derivative, so it is x, derivative of x square is 2x, derivative of 4x is 4, and derivative of 6 is 0. So what we got is y dash is equal to 2x plus 4. So to find the value of x where the maxima or minima is there, we will equate it to equate y dash to 0. So we are writing basically 2x plus 4 is equal to 0. Therefore, x is equal to minus 2. So this is the point where either maxima or minima is exist. Now, if you have to find whether it is maxima or minima, what we will do is we will take its double derivative. So double derivative of y is, which is 2x square plus 4x plus 6 is basically 2, because first derivative is 2x plus 4, and if we differentiate it again, it will become 2. So y double dash is equal to 2. Since it is a positive, y double dash is positive, the given point is minima. So the minima will be at x equal to -2. And what is that minimum value? So if you have to find that minimum value, what you will do is you will put x equal to -2 in given f of x. So if you put f of, so we'll find out basically f of -2. So f of x is x square plus 4x plus 6. So here basically -2 square plus 4 into -2 plus 6. So -2 square is 4, plus 4 into -2 is -8 plus 6. So it is equal to 2. So 2 is that minimum value. So minimum value is like minima is at x equal to -2, and the value of minima is basically 2. So I have, so if we draw this, see this function f of x equal to x square plus 4x plus 6, it will be like this. So here this is the x-axis, this is the y-axis. So if you draw this x square plus 4x plus 6 y equal to x square plus 4x plus 6, the graph will look like this. And as you can see, there is only one like minimum point, which is at x equal to -2, and the value of this x equal to -2 means minimum value is basically equal to 2, because here it is 5. So each division is basically 1. So means whatever we have solved mathematically, we are basically seeing it on graph. I will give one more example for this. Okay. So now we have function x cube minus 3x square plus 4, and we have to find both maxima and minima, their location as well as their value. Okay. So the given function is x cube minus 3x square plus 4. So let's say y is equal to x cube minus 3x square plus 4. Let's take first differentiation. It is equal to 3x square minus 6x, and for 4 it is 0, so it will keep it. Again we will take second differentiation, and it will give us 6x minus 6. Now to find the location of maxima and minima, what we do is we equate y dash or first derivative to 0. So let's say y dash, we will equate it to 0. Okay, so let's take y dash is equal to 0. Therefore 3x square minus 6x is equal to 0. We will take 3x as common, so we get x minus 2 is equal to 0. So in this case, means this equation means this equation will be 0 only when if either if x is equal to 0 or either x equal to 2. So these two are the roots of this equation, and basically these two are the point. We don't know which one is maxima, which one is minima, or both are maxima. Means both cannot be maxima minima in single region. But okay, we don't know exactly which one is minima or maxima. To find out that, we will substitute the value of x into y double dash. So let's say for x is equal to 0, y double dash is will become equal to 6 into 0 minus 6, that is minus 6. It is minus 6. So since y double dash is negative, this x equal to 0 is point of maxima. And if we have to find out this value of maxima, we will put x equal to 0 in this f of given f of x. So if you put x equal to 0 in this given f of x, it will become 0 cube. 1 second. So it will become 0, it will be 0 cube minus 3 into 0 square plus 4. So it is equal to 4. So 4 is the value of maxima, which is at x equal to 0. Similarly, if you put x equal to 2 here, then in this case we will get y double dash as 6 into 2 minus 6, which is equal to 6. So it is plus 6, and therefore this x equal to 2 is point of minima. And if you have to find out the value of minima, you will put x equal to 2 in f of x. So what you will get is uh, it is like x cube minus 3x square plus 4. So minus 3 into 2 square plus 4. So 2 cube is 8, minus 3 into 4 square is 2 square is 4. So it is 12, minus 12 plus 4. So it is equal to 0. So minima is at point x equal to 2 and value of minima is 0. And maxima is at point x equal to 0 and its value is 4. So if you see the graph, you can easily find out. So this is the point of maxima. So it is at x equal to 0 and its value is like 1, 2, 3, 4. It is 4. And if you see this minima, it is at location x equal to 2 and its value is 0. I think this was all for differentiation part. So please ask if you have any question, at least respond like whether you have any question or not, so that I can proceed further. No questions. Okay. Pranjal and Rima, are you there? Like, do you have any questions? Okay. So now we will start with integration part. Oh, okay. So we'll start. So integration is basically the inverse of derivative. So whatever we have learned in derivative. So like if we have function y equal to x and its derivative is let's say derivative of one x was 1. So if you find the integration of 1, if you find integration of 1, it will be x. So integration of 1 is basically x. So or x plus constant. So integration is antiderivative, or you can say it as an antiderivative, or it as inverse of derivative. And actually integration means the, let's say if you have some curve f of x. So if you are finding the integration of this, so one second. So integration is basically the area under this curve. The quantity, the value of, if you get, if you have function f of x and if you find its integration with respect to x, so it will give basically area under the curve and basically the x-axis. So this is x, this is f of x. So integration gives you the area under the curve. So in future, like in when you will study the rectilinear motion, so in the rectilinear motion, uh, you know the concept like displacement or velocity or acceleration. So velocity is basically differentiation. So if s is the displacement, then the velocity is derivative of s with respect to time. And acceleration, or let's say if v is the velocity, then acceleration is differentiation of velocity with respect to time. On the other hand, like if you draw, okay, if you draw the if we have velocity versus time curve, so as I told, like, uh, and if you have velocity time curve, if you take the area under this curve, if you calculate the area under this curve, this will give you displacement. So both derivative and like integration are inverse to each other basically. Then there are two types of integration. First is indefinite integration, where he- see here we have function f of x. So integrate. So this is the integration sign. So the integration of f of x is basically here given as capital F of x plus c. So we add c in this case because, let's, as I told you, like, derivative of x is equal to 1, but what the derivative of, let's say, x plus 4, so it is also equal to 1. So since the derivative of 4 has become 0, we have not written it over here. So derivative of x as well as x plus 4 both are 1. So if you are finding now the integration of, let's say, 1 with respect to x, you will write it as x. But since they are antiderivative, this 4 term have not been considered here. It can be 4, it can be some 100, or it can be 0 also, like. So for just to represent that term, we write here c as some constant. And the second one is indefinite integral. So sorry, definite integral. So in definite integral, so what was the integration of f of x? Let's say it was f of x. So in this definite integral, we will not just simply write it as f of x, let's say f of x plus c. So we will also put the value of limit, like, it is, since it is from a to point b, so we will write it as f of x plus c from point a to b. So now we will put the value b and a here. So if you put the limits, like f of b here plus c minus f of a plus c. So cc will get cancelled, and finally you will get f of b minus f of a. So therefore in definite integral we don't write this constant term here, because it get cancelled. And okay, so this was the uh, part of some basics about integration. So now we'll see the basic formulae which are there in integration. So if we have to, so first we will see the indefinite integral, where the limits were not mentioned. So now if we see, if we have to find out integration of x to the power n dx, then its value is, its integration of x to the power n dx is given as x to the power n plus 1 divided by n plus 1 plus c. Okay, so if you have a function, let's say f of x is equal to x square, and if you have to find out its integration, integration of f of x dx, or integration of x square dx, then using above formula here, x, we have x square, so n is equal to 2. So from above formula we will get integration as x 2 plus 1 divided by 2 plus 1 plus c. So it is basically x cube divided by 3 plus c. Similarly, if you have to find out the integration of 1 using same formula, so for even though 1 is constant, you can write it as x to the power 0, because anything to the power 0 is 1. Therefore, if you have to find out its derivative, you can write it as x to the power 0 into dx. So here n is equal to 0. So its integration can be given as x to the power 0 plus 1 divided by 0 plus 1 plus c. So which is equal to x plus c. One thing you should note down that this formula is not valid when n is equal to minus 1. Okay, this formula is not valid for x equal to n equal to minus 1. For rest all other values, this formula is valid. So like, let's say one more example. If you have f of x is equal to x to the power 6, then integration of x to the power 6 dx is basically x to the power 7 divided by 7 plus c. And the issue with x to the power like x to the power minus 1 is that, or if you have to find the integration of x to the power minus 1, let's say if function is f of x is equal to x to the power minus 1, so it is equal to 1 by x. So as you have seen in the differentiation, that differentiate d by dx of log x is equal to 1 upon x. So therefore, since differentiation and integration are inverse and opposite, so the integration of 1 by x dx is basically log x plus c. So these thing you should always remember. So let's see a constant. Let's uh, like if y is equal to 5, let's find its integration. So again, if you have 5, you can write it as 5 into 1, and if it is 5 into 1, 5 into x to the power 0. So if you are finding its integration, so again it will become 5x plus c, because integration of x to the power 0 dx is x. So it will become 5 into x. You can take 5, you can basically you can take 5 outside, and you can write it as x to the power dx plus c. So it is 5x plus c. So if you have some constant value, then simply you can write it like this. Next one is y equal to e to the power x. So as you know, the differentiation of e to the power x was like, if you have to find out dy by dx, it is also e to the power x. Similarly, if you find derivative of sorry similarly if you find integration of e to the power x dx, then it is also same, plus only c will come, because as I told, if it was e to the power x plus some constant, then its derivative was e to the power x. So to manage that, when you take the integration of e to the power x dx, we add one c, and this c can be 0 or it can be any other constant. Okay, now let's see the integration of log x dx. So integration of log x is given as x log x minus x plus c. So this is also, you will have to remember that integration of log x is x log x minus x plus c. Now we will see the integration of different trigonometric functions. So if you have to find out integration of sine x dx, okay, then the integration of, as you know that like, mm, as what we have seen is the differentiation of sine x, like d by dx of sine x was cos x, and d by dx of cos x was minus sine x. So so now uh, if you have to take the integration of sine x, so since both are inverse, so integration of sine x is basically cos minus cos x. So because the differentiation of cos x was minus sine x, the if you take integration of this, if you take integration of this integration and differentiation will, since they are inverse, it will cancel with each other. So what you will get is cos x is minus sin x, integration of minus sin x dx. So therefore from there you can get integration of sin x dx is basically minus cos x. I will try to write it once again. Okay, so what we know is d by dx of cos x was equal to minus sin x. Now if you take the integration on both side, so if you take integration on both side here, integration and differentiation, since they are inverse, it will get cancelled. So you will simply get cos x. So cos x is basically minus of integration of sin x dx. And if you bring this minus side here, you will get integration of sin x dx as cos x. So similarly, we will write for others also. So integration of cos x dx is basically plus sin x plus c. Then if you write integration of sec square x dx, then it is tan x plus c, because the differentiation of tan x was sec square x. Therefore, integration of sec square x is basically tan x plus c. Similarly, if we take integration of cosec square x, then it is minus cot x plus c. So you will have to remember this, as you know that differentiation of cot x is minus cosec square x, and therefore integration of cosec square x is minus cot x plus c. So now let's see some questions of, or some formulas for ax plus b type of trigonometric function. Okay, so if, as we have uh, seen, like integration of sine x dx is given as minus cos x plus c. So if you have to write down the integration of sine ax plus b dx, then its answer is, it will be like minus cos ax plus b divided by a plus c. The only change is since here x is multiplied by a, here below this cos x term, cos ax plus b term, we have divided it with a. So this is valid for all four identities we have seen above. Like if it is integration of cos ax plus b into dx, then it will give us sine ax plus b divided by a plus c. Similarly, if you have sec square ax plus b dx, then it can be written its integration can be written as tan ax plus b divided by a plus c. Again, if you write cosec square ax plus b dx, integration of cosec square ax plus b dx, then its answer is minus cot ax plus b divided by a plus c. You just see the pattern and it will be easier for you to remember this. You just only miss if instead of sine x, if we have sine ax plus b, then the derivative, sorry, its integration will be like instead of sine ax plus b, we will have here cos ax plus b divided by a. So here whole term will remain same, only it will be divided by a. That is the extra addition. In similar manner, like if we have to find out integration of only 1 upon ax plus b dx. So from, like, you know that like log of a, if we have log of x plus b and we find out its derivative, then it will be 1 upon ax plus b, and using chain rule again we will find out derivative for x plus b, which is equal to a. So here, as you can see, if you have to find out the derivative of sorry, integration of 1 upon ax plus b dx, then basically it is equal to log of ax plus b divided by a. Okay, so it is like this only. Like if you integrate this, if you integrate this part, so only the difference is you have divided both side by a. So if you divide this by a and this side by a, you will get integration of 1 upon ax plus b. Here integration differentiation will get cancelled, so integration of 1 upon ax plus b is equal to log of ax plus b. And if you have integration of e to the power ax plus b, then also the result will be same. It will be like e to the power ax plus b divided by a plus c. Plus c is always there, remember that, in indefinite integration. So let's see few examples to understand whatever we have learned. So let's say you have to find integration of cos 4x plus 2 dx. So integration of cos ax plus b was like sine ax plus b by a. So here we will have sine, here this is ax plus b. So a is 4, b is 2. So here we have sine x 4x plus 2 divided by here a is 4 plus c. Similarly, if you have to find out the integration of 1 upon 2x plus 4, then it is equal to log 2x plus 4 divided by here also we can write ax plus b. So this a is equal to 2. So divided by 2 plus c. Again, if you have to find out the integration of e to the power 10x dx, then it is equal to e to the here A is equal Ax, again if you write Ax plus B, here A is equal to 10, B is equal to 0. So here also you can write mm, e to the power 10x by 10 plus c. This is how you can find out the integration of these terms. I think this part is not very much difficult. Again, if you have only cos 2x dx, so similarly here also b is equal to 0 and a is equal to 2. So its integration is basically sine 2x by 2 plus c. Just remember the formula. I think everything else you can easily find it out. And now we will see the few examples of definite integrals. So let's find out the integration of x to the power x dx from 0 to 5. So integration of x is basically x square by 2 because it is x to the power 1. So how we will find out x to the power n plus 1 upon n plus 1. So since n equal to 1, it is x square by 2. Okay. So in definite integral either to the constant get cancelled, so we don't write here c, we will just write it as x square plus 2 and the limit value 5 to 0. So we will now substitute this value, like it will be 5 square by 2. So this value which is on top we will put it first. So it is 5 square by 2 minus, then we will subtract this value, uh, subtract the value, and then we will put the lower limit. Okay, so it is 0 square by 2. So it is basically 0 square by 2 is, this term is 0, so we got 25 by 2. So similarly, if the limit was from, for same question, limit was from 2 to 4, let's say dx. So again its integration is x square by 2. We will not write c as it will get cancelled. So 2 to 4. So first this is upper limit, this is lower limit. So we'll first put upper limit, which is 4. So it is 4 square by 2 minus 2 square by 2. So the value is like 4 square is 16, 16 by 2 is 8, 2 square is 2, 2 and 2, 4, 2 square is 4 and 4 by 2 is 2. So that will give us 6. We will take one more example. Uh, let's say we have a function from 0 to pi by 2. So let's say we have angle 4 theta plus 3 and here d theta. So it's, as we have seen, it's integration of sine theta was basically cos theta, and integration of sine a theta plus b was cos minus, sorry, integration of sine theta was minus cos theta, and integration of sine a theta plus b was minus cos a theta plus b divided by a. So since here it is a definite integral, again I'm telling we will not write constants because it will get cancelled. So the integration of this part is minus cos, one second, minus cos 4 theta plus 3 divided by 4, and we will write the upper limit and lower limit, which is 0 to pi by 2. So now we will substitute these values. So minus cos 4 into pi by 2 plus 3 divided by 4 minus, I'm sorry, actually this sometimes this pen don't work properly, cos 4 into 0 plus 3 divided by 4. So see, this was minus, already minus sign here. If there was minus sign here, so this will become minus minus plus. So if you solve, you will get some value. Okay. So just last thing, like if if you have to find integration of, let's say, sine square x dx, so you cannot find it out directly. But in yesterday's trigonometry class, what we have seen is, like, for we have seen cos 2 theta can be written as, one second, this pen is not working properly. Okay, we have seen cos 2 theta, double angle formula. Cos 2 theta was cos square theta minus sine square theta. Okay, so now as we know that cos square theta plus sine square theta is 1, we can write this cos square, we can write this cos square theta as, okay, I will write down it again. So from double angle formula, we have cos 2 theta as cos square theta minus sine square theta. And we know that, like, sine square theta plus cos square theta is 1. So cos square theta is basically 1 minus sine square theta. So if we substitute this identity in this equation, we will get cos 2 theta is equal to 1 minus 2 sine square theta. And therefore, sine square theta can be written as 1 minus cos 2 theta divided by 2. So now, instead of solving this sine square x dx, we will replace it with 1 minus cos 2x by 2. So integration of, if you have to find integration of sine square x dx, you will write it down as integration of 1 minus cos 2x divided by 2 dx. And so here you can basically, integration of 1 by 2 is 1 by 2x, and integration of cos x was basically sine, it will be sine 2x by 2, so it will be minus, it will be like this, plus c, since it was indefinite integration. So do you have any questions in integration part? I think this much of integration and differentiation is sufficient to understand physics for NEET exam. So please tell me if you have any question in this part of integration and differentiation. So Rima and Pranjal, do you have any question? Okay, so I think, means, for today we will stop, and in next class we will study the vectors. And vectors is also really important for understanding physics. And then after completing vectors, we will start with class 11th physics syllabus. Okay, so if you face, like, if you try to study it, I will try to share notes by next Friday for both trigonometry as well as differentiation and integration class. And in between, if you get any doubt, you can message me, and then I will, maybe we can, I will, if it is easier, then I will give the solution on WhatsApp only, or we can set up a meeting on Tuesday or Thursday to understand if you have any doubt in this differentiation, integration, or trigonometry. Okay, so we'll meet on next Saturday. Is it fine? I will also give you practice problems on mostly by Wednesday, so you can try to solve that. And if you face any issue in solving this practice problem, you can ask me. Yes, yes, it will be completed on time. I'm just wanted to uh, like teach mathematics, because mathematics is very important for physics, and many students drop mathematics course when they are preparing for NEET exam. Yeah, so it will be done on time. Yes, for both 11th and 12th. Yes. Do you want to ask anything? Okay. Okay, thank you so much. So we'll meet on next Saturday. But if in case you are having any doubt, you can message me on WhatsApp. I am always there to solve your doubts. Okay. Thank you so much. Bye.